Oh yeah, kuatkan radio, kuatkan radio anda. Kuatkan radio, kuatkan radio. Aku yang patuh, yang betul, memberinya segala. Kerana aku mampu, melakukan apa-apa saja.
Objectives of the experiment is to observe and record the frequency of each color of the marbles. Other than that is to calculate the experimental and theoretical probability of obtaining each of the color. Lastly is to find the differences between experimental and theoretical probability of the experiment. Significance of the experiment. This study is carried out with the aim to help us understand and learn more about probability and how it plays a big role in our daily life. This project consists of picking up 30 marbles with 3 different colors, randomly with replacement. As a result, we can evaluate the probability of the outcome, whether red, blue or green will appear. Moreover, we can apply the experimental and theoretical probability formula as well as increasing our understanding of the differences between the experimental and theoretical probability.
Okay, so we have done the experiment where we randomly pick marbles with 3 different colors out of 30 marble with replacement. So the result was recorded in this table 1. Okay, so first, the total marble for red marble is 8, 10 for blue marbles and 12 for green marbles. Okay, so next, from our observation, we have found that the frequency for red marble is 10, 7 for blue marbles and 13 for green marbles. Okay, so to find the experimental probability of obtaining red marble. So first, you need to know the frequency for red marble. So from the table 1, we know that the frequency for red marble is 10. So we divide 10 with the total marble, which is 30. So we got the experimental probability of obtaining red marble is 10 over 30. So for blue marble, we know that the frequency is 7. So 7 divide with 30. So we got 7 over 30. For green marble, the frequency for green marble is 13. So we divide 13 with 30. Okay, so next, for theoretical probability, we need to divide the actual marble for each color and divide with the total marble for our experiment. So for red marble, the actual total number for red marble is 8. So we divide 8 over 30. For blue marble, the actual total number for blue marble is 10. So we divide 10 over 30. And for green marble, the total marble for green color is 12. So we divide 12 with 30.
For question D, to find the difference between the experimental probability of obtaining red marble and the theoretical probability of obtaining red marble, we have 10 over 30 for experimental probability and we have 8 over 30 for theoretical probability. To find the difference, we have to do experimental minus theoretical and multiply by 100 and we can get 6.67%. For question E, to find the difference between experimental probability of obtaining blue marble and the theoretical probability of obtaining blue marble, we have 7 over 30 for experimental probability and we have 10 over 30 for theoretical probability. To find the difference, we have to do experimental minus theoretical multiplied by 100 and we can get negative 10%. For question F, to find the difference between experimental probability of obtaining green marble and theoretical probability of obtaining green marble, we have 13 over 30 for experimental probability and we have 12 over 30 for theoretical probability. To find the difference, we have to do experimental minus theoretical probability and multiply by 100. We can get 3.33%. For question G, to find the experimental probability selected marbles are not red marbles, we have 10 over 30 for experimental probability of obtaining red marble. So to find experimental probability of obtaining not red marble, we have to do 1 minus 10 over 30 and the final answer is 2 over 3.
Proceed to question for experiment 3. The question that we got is fx equals to 3 over 50 times in bracket x squared minus 4x plus 5, where x is bigger than 0 and less than 5. The first thing that we need to calculate is ex. How to find ex? We need to find ex by using formula x times fx dx. After that, put the equation into the formula. Then we can proceed with the integration. The answer that we got for this question is 25 over 8 or 3.125. Next, find the cumulative distribution function of random variable x. The symbol is capital Fx. First, we need to substitute x in the original equation into t. So the equation becomes 3 over 50 times in bracket t squared minus 4t plus 5. Next, integrate the equation to become into integration of lower limit 0 and upper limit x. After that, integrate as usual. The answer that we got is 1 over 50 x cubed minus 3 over 25 x squared plus 3 over 10 x. That is our capital Fx. For question C, by using capital Fx, find probability of x is bigger than 2.5. To find the probability of x is bigger than 2.5, we need to use 1 minus fx. Then we substitute the value 2.5 into the formula. Then we got 1 minus f 2.5. The answer that we got is 11.60. For the last question, using fx, find x is bigger than 1 and less than 2.5. The probability of x is bigger than 1 and less than 2.5 is, we need to find it using f20, 2.5 minus f1. The answer that we got is 9 over 8.
Based on the experiment, the probability of getting red marble is higher than blue marble and green marble. The percentage of the difference between experimental probability of obtaining red marble and the theoretical probability of obtaining red marble is 6.67%. In conclusion, we have already achieved our objective, such as to observe and record the frequency of each color of the marbles. Second, to calculate the experimental and theoretical probability of obtaining each of the colors. And finally, to find the differences between experimental and theoretical probability of the experiment.